So chapter 3 is all about functions, and we're going to be learning in this video exactly what a function is. But first, we're going to start with a mapping. And a mapping is simply just a set of ordered pairs. Ordered pairs. Remember ordered pairs? X's, Y's? We're going to talk about that more in just a second. And a set of ordered pairs takes us to a relation, which I'll go ahead and put right down here since I just answered that blank. So what exactly is an ordered pair? Now let's get to the nitty-gritty of what that is. So yes, an ordered pair comes in the form of x comma y. That's how we write it in algebra class. But what does it show? Well, an ordered pair shows a relationship between an input and an output. Shows a relationship between an input and an output. So we've got a lot of vocab in this chapter. Input and output is certainly one of them. Ordered pair, yes, one more time. An ordered pair comes in the form of x comma y. And a relation is a set of ordered pairs. So let's keep going. Here are ways that we can illustrate a relation. So here are two on the sides that you're probably very familiar with. This is the graph of 1, 2, 3, 4, 5 points. And those same 5 points are listed in this XY chart. And of course, we can also show a mapping. So if -1 corresponds with +1, you can see that here. -1 maps to +1. 0 corresponds with -1. When x is 0, y is -1. X is 1, y is 3. 1 maps to 3. 2, -2. 2 maps to -2. And 3 also maps to 1. 3 maps to 1. So 3 ways to describe a relation, and all 3 of these illustrations are showing you the exact same information. Whether we put it in a table of values, a graph, or map it, they all 3 mean the same things. Now probably these first 2 are the ones that you are most familiar with. So, is the relation a function? So here's the definition of a function. Write this down. Even if you need to stop the video, stop it and write it down in your notes. A function is a relation in which each input is paired or mapped, if you want to say that, with exactly one output. Let me read it again. A function is a relation in which each input is paired with exactly one output. So, summing it all up, in order for a relation to be a function, the input values never repeat. So, if we look back at the relation we were just examining, it appears to me that in the table of values, all of the x values are distinct. Now, we have a y value that repeats, but that's okay. Here's the deal. When we plug in -1 as our input, it only takes us to +1 as our output. So, if we look at the definition one more time, a function is a relation in which each input is paired with exactly one output. So even though the output value 1 is repetitive, it doesn't matter because each x value are only mapping to exactly one output. So yes, this mapping is a function. This mapping, this table of values, this graph, they all represent a function. So, Here's another one that is a function that I think you'll find interesting. So this C equals 12 times S minus 65 plus 25. This is a function, and it represents the cost of a speeding ticket. Now, C is the cost, and S is the speed over 65 miles per hour. So we're saying you can't even get a speeding ticket if you're not going, until you're going 65 miles per hour or greater. So here is a chart I've constructed. We're going to take our input values and show that we only get one output value when we plug in 70. So let's do that here. C equals 12 times S equals 70. So I'm plugging in, I'm substituting in 70 for S. 70 minus 65 plus 25. Following order of operations here, 70 minus 65 is 5. 5 times 12 plus 25, that's 60 plus 25, that is 85. 85. So if you're in a 65 mile per hour speed zone, you get caught going 70, your cost of your speeding ticket will be $85. Let's do it again. This time, we'll plug in 75. Let's see what happens. So that means 75. Let's do a little part of it in our heads here. 75 minus 65 is 10. 10 times 12 is 120. 120 plus 25, 145. So as we can see here, the cost is increasing, and it's not going to be duplicated in any of these. 70 only maps to 85, nowhere else. 75 only maps to 145, nowhere else. Let's plug in 80. 80 minus 65 is 15. So I'll use my calculator here to help us out. Let's focus on it if we can. Try one more time. A little better. There. So here we go. So let's plug this in. So we're plugging in 80 into this ticket function. So the ticket function says take 80, subtract 65. So 80 minus 65. So 12 times 80 minus 65 plus 25. So if you're going 80, your ticket cost is now $205. Now, hopefully what I hope you see happening here is when we went from 70 to 75, the cost went up by 60. When we went from 75 to 80, the cost went up by 60. What's going to happen if we go up to 87? It's going to be more than 60. Let's plug in 87. 12 times 87 minus 65 plus 25, 289. But I do want to reiterate the point. It's not going anywhere else except that one number. We only get one thing when we plug in one input. And finally, 95, just so you can see, if you're really excessively speeding, 95 minus 65 plus 25. And yes, ladies and gentlemen, I did just make up this function. This is actually not how it is in the state of Florida. But what you can see here with this chart is when I plug in one input, I get only one output. It only maps to one place. So, does this represent a function? According to the definition, a function is a relation in which each input is paired with exactly one output. Yes, that does represent a function. So, what is not a function? Well, here's something that's not a function, and if we were all in class together, this would be a little more interesting. But let's consider a machine where you input an age, and the machine gives you the name of a friend who is that age. So I have some friends, and if I put in 49, which is my age, how many friends do I have that are 49? Well, I have a friend named Amy, that's 49. I have a friend named Effie that is 49. I have a friend named Julie that's 49. I have so many friends and their names and they're all 49. Is this a function? No, because according to our definition of a function is a relation in which each input is paired with exactly one output. Well, I put in the input 49 and I quickly came up with 4 names of my friends that are all 49, so this can't be a function. If we were to go to CCA, our school, and say, okay, let's input 16. How many people in our school would be 16? Way more names that'll fill in that blank. The same thing with 17 and the same thing with 18. So is this a function? No, not a function. It can't be a function because a function is a relation in which each input is paired with exactly one output. And this age machine, this machine where we're inputting an age and getting a name, is definitely going to take us to places that is definitely not a function. So what is a function? What's not a function? What is a relation? What is a mapping? That is the very beginnings of chapter 3.